before diving into the details, let me walk you through the background of wood identification in Taiwan. Taiwan has abundant forest resources with various wood species that serve distinct purposes and have significant price variations. To maximize the utility of wood timbers and avoid economic losses caused by misidentification, accurately identifying wood species is a fundamental and crucial step. In Taiwan, wood identification is in high demand, especially in combating illegal logging and managing driftwood removal. According to forest regulations in Taiwan, these huge amounts of driftwood must be cleared and marked within 1 month. Make rapid wood identification method essential. However, conventionally, the species of wood logs were identified through a series of histological treatments under microscopes by experts. This method also is high accuracy, but it faces several challenges like it's time consuming and it has shortage of experts in Taiwan. And the other method is use macroscopic analysis like smell, texture, or the color just by experts' naked eyes. And this method easily goes to subjective judgment. Therefore, this research proposed an automatic wood identification system for efficient and objective identification. And next, I will walk you through the method used in this research, followed by the key result we obtained. The proposed system is composed of 4 components: a Chatbot interface, a color calibration module, OB detection module, and a wood identification module. The workflow starts when a user uploads an image via Chatbot. The Chatbot controller then sends the image to the backend. First, the image goes through color calibration to reduce device-relevant color differences. Then the OB model checks whether the image is from a known wood type and whether its qualified is acceptable. If the image is valid, the system identifies the wood species and returns the result to the user. And in this research, 41 commonly found wood species in Taiwan were collected, which serve us in distribution. Additionally, 16 non-target species and 5 types of defective samples, such as tree nuts, incomplete surface treatment, non-cross section, scratches, and drying crack, were included for out-of-distribution detection. And for our identification model, we adopted a 2-stage training pipeline. First, we train scanner images. It's because scanner image can provide high-resolution images and allow for quick and large-scale collections. And then we fine-tune smartphone images to help it adapt to real-world conditions. For the wood identification model, the overall accuracy on smartphone images reached 94.71%. And the video shows how we collect the smartphone images. Okay. And for our OD detection model, to train the OD detection module, we selected 41 target species as the in-distribution data set, and we also collected defective samples and non-target species images as our OD data set. And the feature extractor used here is the same vision transformer encoder that was trained during the wood identification model training. And we use it to extract feature vectors from images and to train a support vector machine with RV kernel to detect all these samples. And this is the result of the detection model. And we also apply color calibration module to mitigate color differences between different devices. And we captured Pantone standard color pages using both scanner and smartphone, and mapped smartphone LV values to scanner LV values using quadratic linear regression. And the mean color difference delta E decreased from 13 to around 3 after calibration, as we can see on the figure. On the left is we have uncalibrated smartphone images, and in the middle is calibrated smartphone images. And as you can see, the calibrated smartphone images are usually much closer to the scanner image. And lastly, let me introduce the Chatbot interface. And to make the system user-friendly, the entire system was employed on a cloud platform. And here's a short demo video of our live Chatbot in action. User can upload the cross-section images. The Chatbot returns the top 3 predictions with called confidence scores, along with a link to detailed species information. And the link is linked to Forward Product Technology Platform for those who want to get more with some information. And to sum up, this study proposed a smartphone face identification system integrating all the detection, color calibration, and Chatbot interface. And the OD detection model achieved accuracy of 98.5%, and the species identification model achieved 94.71% on smartphone images. And we hope the proposed system provides a more efficient and objective method for Taiwan's wood application. And I would like to acknowledge Taiwan Forestry Research Institute for their assistance in image collection and financial support for attending this workshop was provided by National Taiwan University. Thanks for your listening.